I'm Srinivas working as assistant professor in IARE College. Today we'll see the join operators in SQL. In SQL, what is the join operators? So why do you use joins? We use joins because your data is normalized and it is break into multiple tables. The data is there in multiple tables. The table is there in multiple tables. And as part of the normalization, you have used up to third number form, and you have made sure that your tables are in multiple tables. Now you want to join all these tables back into the all these tables joined into to provide you a meaningful data. So the SQL provides you a convenient operation to retrieve information from multiple tables. This operation is called join. The join operation will combine the tables into one large table with all the possible combinations, and then it will filter the rows of this combined table to yield the useful information. By using the foreign key relations, we can establish relation between two or more tables by using the joins. Okay, for example, you have the student table here, you have the student table here, and you have one more table called library. You have one more table called library. You have one more table called as score. Hmm? Okay. Now, a student, this is a master table. It will have the student details. In the library, you will have what the student has taken books from which from what books he has taken, and the score will see what is the marks obtained by a student. So, as a part of the normalization, your student data is scattered across these three tables: one, two, three. Now, all these three data is if you want to combine I want to show the list of books books list of books issued to a student called to issue a student number whose roll number is 103. Then I have to query the library database. And I have to display the list of books. So now here the student ID is a master table. In this second table there will be a student ID also. Column is there. Score also, student ID is there. By using the now these three tables are in the relation. So by passing this the primary key, we are going to get the data from these three tables. So so by using the by using the by using joins, we can combine the data coming from one or more result sets. Okay, now we have some types of joins. Those are inner joins. Okay, first you'll see we have joins, inner join. Then we have left join. Then we have third is right join. Then we have full join. Then we also have self join. We also have they called self join, and we have cross join. So we have six joins in DBMS. So each will have its own characteristics. Now we'll see what is the first condition is inner join. Inner join or join. Inner join is that matching records from both the tables will be displayed. I have here two tables, table 1 and table 2. Table 1 and table 2, matching records from both the tables will be displayed here. Now if you see this, the matching records is the item in the shade region. So here what's happening is in the inner join is going to display data from the going to matching data on both the tables. So here you'll write select star from students. This is having you 4 records. So ID, name, and branch ID. So we have 4 records here. What is the second table? You have branches here. You have branch ID 2. You have 6 branches here. Six branches and 4 students. So if you need to display students and their branches, if you want to display students and branches, you should not be seeing ECE because there is no student with who is studying in ECE, so triple E, and also studying in production. So you have to use a join. We have to use a join operator. So join operator is two tables, two table one, table one, table two. In between there will be a join keyword, and after these tables, say two tables, table one, table two, in between join, and we have to use what is a common column between these two tables. So on table one, T1 dot column is equal to T2 dot column. So T2 dot column. So your inner join is the combination of mixed matching records. So you have four records here. So I want to display select student ID from first table, first student name first table. I want to say branch name from second table. So second name branch table, and also student ID also from students table one, table one, table two branch, table two branch. In the between, I should have the join operator. So join these two tables, table one, table two, join with these two on a common column. What is the common column here? Branch ID is there here, and it is here. So this is the primary table. This is the secondary table, or the foreign key table. So I'm saying branches dot branch ID. This is equal to this. This is equal to this. So this is the matching condition. See, the matching condition is that my branches dot branch ID is equal to the student dot branch ID. This is the join condition. This is the join condition, and you're joining two tables here, student and student and. So if you see here now, one Srinivas is studying in civil, and two Srini is studying in mechanical, three Govada is studying in computers, fourth is GOV is studying in ECE. There's no records for ECE, for triple E and production because there's no matching student records. There are no matching student records. That is why when you use inner join is to display only the matching records from the both the tables, matching records from both the tables, and that's why you're not seeing a data. You're not seeing the data which is not there in triple E and production and triple E production. Now we'll see the left join. So okay, now what is we have seen in inner join means the data which is common in both the tables. Now we'll see the left join or left outer join. 1 second. You see here you can also write you can also write this inner join in that without using the join also, because inner join you can write same as say students comma branch student comma branch where see select data from table A, table B. I see, and you write the where clause. I'll say where branch dot branch ID is equal to student dot student students dot branch ID. Student branch ID. I'll get only the matching condition because I'm using the where clause. I'm providing the comparison operators. Okay, the left outer join also two tables are involved here. Two tables are involved. In the left outer join returns all the records from the left table. So this is here the table one, table two. Table one is the left table. Table two is the right table. So your left join keyword returns all the records from the left table and the matching records from the right table. So all the records from the table one and the matching records from the table two. The result is null is a null for the right side if there are no matches in the right table. If there are no matches in the right table, it displays null. If there are matches, it will display data. Now here, see left table. Left table is this. Left table is this. This is right table. So all the records for the table 1 plus matching records. If there are no matches, it displays null for the right side table data. Okay, this is the thing. Now we'll try to know the syntax. In order to join two tables, you should have keyword called join. So here table one, table two. See in the between I'll write join. In this case, I want to use the left out to join because I want to have the entire data of the left and the matching record from the right. The no matches display as null. So I'm saying left to join or left to outer join, left outer join T1 T2 on the common column is T1 dot column T1 dot column is equal to T2 dot column. So left outer join is it will give you all the records from the left table plus matching records from the right. If there are no matches for the right, it displays as null. In this case, select branch ID and branch name, student name from branch. My branch is branch. Next, students branch dot branch ID. Now here this is now whatever the table before the join is the left table after the join is the right table. So this have to be kept in mind. What are the table or what is the table before the left table? Before the keyword called join is the left table. What is the table after the right is the right table? After join is right table. So here my branches is the left table. My student is the right table. So this is the left table. This is the right table. Now we are using a left outer join means you should be getting all the records from the branches table. You need to get all the records from matching table. The matching records from the right table. When there are no matches, display as null. So here branches ID. So 1 match, 2 match, 3 match, 4 match. And there is no data for 5 and 6 here. So there is no data for 5 and 6 here. So your output is first you are going to get all the records from the branches. So you got here 6 branches along with the 6 branches names. You got the 6 branches names. Then you write the matching records from the right table. So 4 matches, 1, 2, 3, 4 matches, and there are no matches, and there are no matches for the left table for 5 and 6 because there are no students. There are no students for 5 and 6. By this you're going to get all the data from the left table and the matching records from the right table. And the only difference is that you when there is no matches on the left table, on the right table, you are going to get nulls here. We're going to get the nulls here. Now we will see what is the next join, that is right outer join. Right outer join, right. So we have finished now finished inner join, finish also left outer join, outer join. Now we are going to see right join or right outer join. So right outer join, right outer join is just a reverse of left outer join. Reverse of left outer join. So right join, left join. So in the right join, it is just opposite to the left side. See in the left join, we got all from the left, the matching records from the right. No matches, display as null. See in this case also. Now table 2. No, now this is now table 1, table 2. This is now the right table. Now in the right join, all the records from the table 2 plus matching record from the table 1. No match display as null here. So branches here, and student here. So the right join keyword returns all the records. The right join keyword returns all the records from the right table and the matched record from the left table. The result is null from the left side when there are no matches. When there's no matches, display as nulls here. So here my students is the see again students, and then now I'm writing here branch. Now two tables are in between. We should have a join. Between we should have join. Now here I'm saying right outer join. Right outer join. Now this is my right table. This is right table. This is left table. So anything after the join is the right table. Anything before the left is the anything before the join is the left table. So table A, table B, between join. Anything after the join is the right table. Anything before the join is the left table. Left table. So here I am. See here now I'm writing the actual code here. Select branch ID and branch name, student name from students right outer join branch. Now branch is the right table. Join is the right table. On the matching condition is same. Branches dot branch ID is equal to student dot student ID, student branch ID. So here what is the right table? Branch. So you should be getting all the 6 records from the branches. You should be getting all the 6 records from the branches. So you got all the 6 records. From the branches, and the matching records from the right table. Here only 4 matches. So 1, 2, 3, 4 matches. After 4 matches, display null for the right side table. So you display null for the left side table. Here no student, so display as null. So just opposite. See, in the left table, in the left outer join, all the records from the left plus matching record from the right. In the right table, all the records from the right, all the records from the right, and the matching records from the left. Now we'll see the till now we have completed inner join. We have completed inner join. We also completed left join. We also completed the right join. Now let us see the next join. Full outer join. Full outer join. In the full outer join, the full outer join keyword returns all the matching records from both the tables where the other tables or matches are not. So if there are rows in the branches table that do not have records in the student table. So full outer join is the combination of left and right join. Is the combination of left and right joins. So full outer join is a combination of left and right joins. So table 1, table 2, all the left or full outer join returns all the matching records from both tables, whether table or matches or not. So if they are the rows in branches table, not matches table. So here now we are going to use the full outer join between two tables here. Branch and students here. Branch and students here. We are going to use two tables here. Students and branches. When you use this, so here when you use this, you get all the now here Full auto join is table, student 1, student 2, table 1, table 2, table 2. Then this is the common condition: branch dot branch ID, branch dot branch ID is equal to this branch dot branch ID. Now we should be seeing here all the records from the matching records. So there are 6 records. You should get all the six records, matching records from both the tables, and there are no matches here. Null and here, null and null. So you are going to get here. This is the now. Suppose I have here one more student 5, whose roll number is 5, who is G, and who studying here no branch here. Then 6 GO. Here also 2 records. Here also no branch here. Then I will be displaying here. When I use this, I'm going to get 7th record as dash G dash Go, because here all the 6 records are there. 4 are matching till here perfect, till here perfect. No matching records from the here ECE and triple production you get here. ECE, triple E and production here. Here null. The same way, so student is there but is not assigned any branch. Then it will be displayed as null. Then he will be displayed back as null. He will be displayed back as null. So this is a full outer join. Full outer join is a combination of left and right join. Full outer is a combination of left and left plus right is full outer join. See, entire data from here and here. In the case of right, you got only the right plus matching records. In this case of left, you got data from here. But in the case of full auto join, the entire data from both the tables, matching records, non-matching display as nulls. Display as nulls. Now we'll see a self join. Now we'll see a self join. What is a self join? Joining a table to itself is a self join. Joining a table to itself is a self join. That means that same table is joined to itself. Same table is joined to itself. Okay, table joined to table. Here two tables here. Two tables having the same names, student and student. When you want to join these two tables, then it is a self join. Self join or equi join. Equi join. A self join is a case of regular join where a table is joined to itself based on some relation between its own columns. When there's some relation between two columns in a table, then only we can make it as a self join. Self join uses the inner join or the left join clause, and table alias is used to assign different names to the table within the query. I have here two tables, student and student both. Now I cannot have these two tables. So because they have two tables, now I have to use here table alias. I have to use the table alias. Use the table alias. So student, this is my S1, this is S2. So what is S1? It is a student table. What is S2? It is also a student table, but it is S2. So these are the aliases: S1, S2, S1 and S2. Okay. Now here, if you see here, now here I am what I am doing is that student table, S1 and S2. Now I have this two. Now see these two tables here. Two tables here, student and students. So what is here? The name of the table is student. Here it is as alias. This is the alias name. 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 So I want to display students, student and the name from the second column. See, I want to display student ID from the first table. So this is coming from the first table. This name I want to display from the second table. Names coming from the second table. I'm saying students join same table, student alias you are on the student dot student id is equal to student dot student id, student id. So s dot student id is equal to s dot student id, same here. This is the alias here. So I'm displaying a 1 2 3 4 1 this 1 2 3 4 is coming from the first student, and the name is coming from the second table. This is a simple example of the self join. We can have one more table. We can have one more example of a little more difficult example of self join. We'll see here. Now I have an employee called as employee having columns like employee ID, employee ID, employee name, department, and supervisor. That means that, for example, no. Let me write the data here. One, two, three, four employees. Name A, B, C, and D here. Department is here. It is network. Here it is network. Here it is finance. Network, finance. Here I'll make it as accounts. I'll make it accounts, and I also know this. I'll make it as marketing. Marketing. Now department over. No supervisor. For A, no supervisor. For two, supervisor is one. For three, supervisor is one. For those, supervisor is two. Now see this data here. Now see this careful. This data here. EMPID, e-name, department, supervisor. Four employees, four names, four departments, and here for for the first employee there is no supervisor. For the second employee, second supervisor is one. Okay, so one. A third employee C, supervisor is one. For fourth employee, the supervisor two. Now what is this one and two? They are also workers. These are all the employees who are also employees. One is an employee, one is an employee, two is an employee. So both are these employees, both are these employees, both are these employees, both of them these are employees, and and now they also act as a supervisor. Now they are also acting as a supervisor. Both of these employees, they are also acting as a supervisor. I'll be using a self join. I'm using a self join. Now I want to display the name of the employee. Name of the employee. I want to display the. Now my requirement is to display the name of the employee, name of the employee, name of the employee, and also supervisor. Name of the employee and name of the supervisor. Name of supervisor. This is what I wanted to display now. Now is the supervisor a different table? No, this is also in the same table. Now supervisor is also an employee. Now you can use the self join. Is no. Now try to now we'll try to write an SQL query to print the name of the employee and to print also the name of the supervisor. In order to do these two things, we have to display. We have to use this table twice. We have to use the employee table. We have to use the employee table. We have to use the employee table twice. We have to use the employee table twice. Now we will use the table here. Now select name. Select e name, and also supervisor name also. So supervisor name is as an integer value. Now I also what I'll write okay from for employee. If I execute this, I'll be getting I'll be getting A B C D. Now let me use this on use the other table. Same table once again. Employee, employee, yes. Uh, Employee is the table name, followed by as S. Now this is the first table. This is the second table. I'm using S. Now let me write the join condition. I'll say on. I'll say on. My S is supervisor. S dot S dot S dot supervisor. S dot supervisor is equal to emp dot empid. emp dot empid. emp dot empid. So here, so same table joined twice. emp2, emp as S. This is one. Now S dot supervisor. S dot supervisor is this. S dot supervisor is this is equal to E dot empid. E dot empid. Now if I join this, now I'll be seeing like this. A, no supervisor here. For B, the supervisor is A. Supervisor is A because one here. For C, supervisor is A. For D, the supervisor is equal to B. This is how I'll be seeing data. This is the self join. The self join. We are combining. We are joining the same table twice. We are joining the same table twice to get the required information. Now we'll see the last join. Now we'll see the last join. That is the Cartesian join or the cross join. Cross join or Cartesian join. Cross join, cross join or Cartesian join can be defined as a Cartesian product of two tables included in the joins. So two tables are joined together, and then it is a Cartesian product. A table after join contains the same number of rows as in the cross product of the number of rows in the two tables. If a where clause is used, then it becomes inner join. So two tables, table 1, table 2, cross join means it is a cross product of two tables data. Now here, so here I have you have to also number of rows into number of rows in second table. Now this is my first table. There are 4 records. Here there are 6 records. So 4 into 6 is 24 records. So when you join these two tables, you are going to get 24 records. Each record will be linked with this other records. So one is linked to this one will be linked with 1, 2, 3, 4, 5, and 6. Similarly, 2, 2, 1, 2, 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. So 4 into 6, 24. So 24 records will be displayed here. 24 records will be displayed here. Okay, now how to use the cross join? Table 1 is student, table 1 is student, table 2 is branch. These two are joined with the cross join. So the cross join. So 4 into 6 is 24. 4 into 6 is 24. You are going to get 24 records. So here, so first this is the first set of 12 records. First set of 12 records. This is the next set of 12 records. This is the next set of 12 records. So 12 plus 2 is 24. So you're going to get 24 records. So cross join. So cross join is a Cartesian product between the two tables data. So here 4 records, 4 rows, 6 records, 6 rows. So 4 and 6, 24. So 24 means suppose I say here when you use a cross join, we can mention table name here also same. Same thing I can write as a branch. The table order doesn't match. Branch cross join cross join students cross join students. Now both will give the same output. When we use the cross join, when you use the cross join, is because it could be branches or cross join or cross join students. So also this is the same as students student cross join branch. Both will give you same output. Both will give the same output. So okay, now we have finished all the joins. Now first we will have a small recap of what we have learned in the joins today. Okay, now we'll start with the from the again first. Total we have. So what is the first? We'll see what is a join. Yeah, what is join? A join is your data is normalized into many tables. Data is distributed among tables. We want to display the all the combined data into one result set. Then we use a joins. So in the join you have to use a join operator. We have to use the join operator, and by using foreign key and relations we using the primary key and foreign key relations, we can make use of the joins. Now the types of joins we have the inner join. We have the inner join. In the inner join, matching record from both the tables is displayed here. Table 1, table 2. Matching records is this set. Matching records is this set. So matching records from both the tables will be displayed. So 4 records here, 6 records, only 4 matches. So you are going to get 4 records. You are going to go triple E and production is not displayed because there is no corresponding student. This was the case of inner join. Now we'll go to the next join, that is left outer join. In the left outer join, all the records from the left side will be displayed. The matching records from the right. If there are no match, display as null here. Display as a null here. Student table. So now I'm writing my number. See, I said that table one, table two. In between there is a join condition here, and then also called as on matching columns. So anything before the join is the left table. Anything before the join is left table. Anything after the right table is the right table. Now here the branch is the left table. Students is the right table. The right table. So I want to display all the branches matching records from the right left, no match display as null. So first I got all the 6 records. I got all the matching all the 4 matching records from the left table. No matches display as null. Here. Just opposite to that is the right join. Just opposite to that is the right join. Means all from the right, all the data from the right, plus matching records from the left. So here my right table is branch. So all the records from the all the records from there and no matches from the left display as null. The combination of left and right on is join is the full auto join. The full auto join is the combination of left join plus right join. Right join means entire data from both the tables will be displayed. If there is no matches for this, display as null. There are no matches for this, display as null. So here, if I add one more student, 5 GO, no branch here, branch not allocated. 6 G, no one allocated. Now, if I execute this query, students full auto join, I'll be seeing here 6 records. I'll also seeing the 7th record as a 7th record. The branch ID will be null here. The branch name also will be null here, and I'll see the name of the student as GO. Eighth record is also null for the branch ID, and also null for the branch name. What I'll be seeing the name as G as G. Now after this full after this full auto join, we have the self join. We have the self join. Self join is join the table to itself. So student table is joined to the same table. When we use the same table, there must be some relation to the two tables. There must be some relation to the two tables, and also we need to use the aliases when when you are using the. We have to use the alias when you're using the self join. And the last we have the cross join. The cross join is the Cartesian point between two tables. That is number of rows in the first table multiplied by number of rows in the second table. So here 4 records, 6 records, 4 into 6 is 24 records. 24 records. Now if you see the output here, this is first 12 records, next 12 records. So totally 24 records. With this, we completed the joins session in this topic. So at the last, we'll see the types of joins once again. Okay, inner join, or join, also followed by left join or left outer join, right join or right outer join. Then we had full join. Then we had self join, and at last we have the cross join. Thank you. This completes the joins topic for today. Thank you. Have a good day.
Like, share, and subscribe. Hit the bell icon for more updates.